Welcome to video number 3 for this unit on one-variable statistics. In this video, we're going to focus on statistics and data displays. Data displays like histograms or box plots are very useful for quickly understanding a large amount of information, but often take a long time to construct accurately using pencil and paper. Technology can create these displays as well as calculate useful statistics much faster than doing the same task by hand, especially with very large data sets. Technology is essential for putting the information into forms that are more easily understood. A statistic is a quantity that is calculated from sample data as a measure of a distribution. Statistics are values that are calculated from data, such as the mean, median, mean absolute deviation, or interquartile range. Mean and median are examples of statistics that are measures of center. Mean absolute deviation, or MAD, and interquartile range, or IQR, are examples of statistics that are measures of variability. Although the interpretation must still be done by people, using the tools available can improve the accuracy and speed of doing computations and creating graphs. Mean and median are examples of statistics that are measures of center. A measure of center is a value that seems typical for a data distribution. The mean, also called the average, is the value you get by adding up all of the values in a set and dividing by the number of values in the set. The median is a measure of center that divides the data in half so that half of the values are greater than the median and half of the values are less than the median. Is it better to use the mean or median to describe the center of a data set? The mean gives equal importance to each value when finding the center. The mean usually represents the typical values well when the data has a symmetric distribution. On the other hand, the mean can be greatly affected by changes to even a single value. The median tells you the middle value in the data set, so changes to a single value usually do not affect the median much. So the median is more appropriate for data that is not very symmetric. The median is usually more resistant to extreme values than the mean. For this reason, the median is the preferred measure of center when a distribution is skewed or if there are extreme values. When using the median, you would also use the interquartile range, IQR, as the preferred measure of variability. The IQR is a measure of variability determined by the range of values for the middle half of the data. In a more symmetric distribution, the mean is the preferred measure of center. When using the mean absolute deviation, MAD, is the preferred measure of variability. The mean absolute deviation, or MAD, is a measure of variability determined by the mean of the distances of the data points from the mean of the distribution. Here are two dot plots, each with a mean of 15 centimeters, displaying the length of sea scallop shells in centimeters. Notice that both dot plots show a symmetric distribution. So the mean and the mean absolute deviation MAD are appropriate choices for describing center and variability. The data in the first dot plot appear to be more spread apart than the data in the second dot plot. So you can say that the first data set appears to have greater variability than the second data set. This is confirmed by the MAD. The MAD of the first data set is 1.18 centimeters, and the MAD of the second data set is approximately 0.94 centimeters. This means that the values in the first data set are, on average, about 1.18 centimeters away from the mean, and the values in the second data set are, on average, about 0.94 centimeters away from the mean. The greater the MAD of the data, the greater the variability of the data. These two box plots represent the distributions of the lengths in centimeters of a different group of sea scallop shells, each with a median of 15 centimeters. Notice that neither of the box plots have a symmetric distribution. The median and IQR are appropriate choices for describing center and variability for these data sets. The middle half of the data displayed in the first box plot appear to be more spread apart or show greater variability than the middle half of the data displayed in the second box plot. The IQR of the first distribution is 14 centimeters and 10 centimeters for the second data set. The IQR measures the difference between the median of the second half of the data, Q3, and the median of the first half of the data, Q1, so it is not impacted by the minimum or the maximum value in the data set. It is a measure of the spread of the middle 50% of the data. The MAD is calculated using every value in the data set, while the IQR is calculated using only the values for Q1 and Q3. Thank you for watching video number 3 of 4 for this unit on one-variable statistics.